So, we should have had an interesting investigation. We found that if we divide the circumference by the diameter for any circle we make, no matter how big or how small, the answer is always exactly the same. The circumference divided by the diameter gives us approximately 3.14, which we now know as pi. So circumference is equal to pi times the diameter. If we rearrange using what we know about algebra and linear equations, if I move diameter up to this side, I times it by pi, and that tells me that the circumference, the perimeter of a circle, is just pi times the diameter of the circle. Given that we know the radius is 2 lots of the diameter, we could also write the circumference is 2 times pi times the radius, because 2r is actually the diameter. So sometimes we write circumference equals pi d, as shown, and sometimes we write 2 pi r. The value of pi correct to 30 decimal places is as we show here. We can do it up to 100 and even more. It's an infinite number. In practice, we use approximately 3.14. It's good enough for everything we do, and this is rounded to 2 decimal places. Or else we use the appropriate key on our calculator. So if we're calculating something with the technology, we just press the pi button and it's using a lot more decimal places. We round off the final answer after we've calculated everything in a calculator. So there's a lot more decimal places in the pi. Once we get the final answer, we just round it down. Using what we've just discovered about the relationship between the circumference of a circle and its radius, answer these questions. Using 3.14 as our pi, we're given here the diameter, here we're given the radius, and here we're given the diameter again. So use that relationship to find out what the circumference is. Here are the solutions. Again, using the calculator for 2 decimal places, find the circumference of a circle with this radius, this diameter, and this radius, cylindrical deodorant can, and a circular pond. And answers below. Now we're looking at some worded problems. So if we had a car tire with a diameter that we knew, we want to find the circumference. What about if the tire rotates 20,000 times? How many kilometers would be traveled? So you need to think about that one a little bit, about the circumference that's rolled over. We know how many times that's rolled over, so we can calculate a distance. And then this is sort of using the other process. If we know the distance, we want to know how many times has it rotated. Solutions below. Another worded problem, if we had a circle with the same perimeter as a square and the side lengths of 8 centimeters, what is its radius? And then we've got an athletic track. So think about the shapes this makes. This is basically a rectangle or a square, and we've got 2 half circles on either end which make a circle. And they tell us enough information to be able to calculate all of these pieces. Solutions below, again.